So you can see that I've put alpha in here, which is no problem. And now I want to find the x bar difference. So you know what? I'm going to have to actually type in the table. So let me go do that. Hold on one second. There we go. Now it's put in. That'll make things go a little faster. So the mean difference is the difference in speeds. So it doesn't really matter which one we put first and which one we put second, to be honest. So I'll just, I don't know, take 269, take away 260, enter. So there's my x bar. And now the big square root, what I'm talking about there is the big square root of the test statistic, because that's what step 3 is all about. So I found that this difference in x bars was 9 or whatever it was. And remember, the difference here is 0 because our null hypothesis is that there is no difference, so we don't really need to worry about that. And it's always going to be 0 for this book. Is it always 0 in real life? No, not really, but for our purposes, it's fine. So now I need this big square root thing. So equals SQRT. And then it's just like before, we're going to have to take S1 squared divided by N1 plus S2 squared divided by N2, which is sample size. There we go. All right, so then I'm test statistic. Now, why am I doing all of that separately? You don't have to if you don't want to, which I didn't in the last video. But it helps when you have to go make your confidence intervals later on, which I'm not actually going to do with you, but it's nice. All right, so the test statistic is this number divided by that number, because technically the numerator is minus 0. And there you go. Test statistic is 0.845. Cool. All right, now step 4, which we never have time to finish in this, but that's all right. We'll start it. Let's do the classical way. So the classical way is we're going to need a critical value. Actually, we're going to need 2 of them, right? Because this is a two-tailed test. All right, so that's going to be equal to t dot inverse dot 2t alpha. And the degrees of freedom, they're the same, so it doesn't really matter. So just pick one. You would go with the smaller one, but since they're both the same value, it doesn't make any darn bit of difference. So you get 2.032, and that's the positive one. So the other critical value would be equal to the negative of that. Okay. If you're doing old school Excel, it's t inverse 0.05 comma degrees of freedom. Remember, old school Excel is, oopsie, yes, I know, that was my fault. Old school Excel does two-tailed tests fine. It's the one-tailed test that it's annoying about. So t inverse automatically is two-tailed as far as old Excel is concerned. Excel 2007 or earlier. Oops, I did that wrong. I want to drag this one over. Right, negative of that. All right, so you can see you're not going to reject. Hopefully you can see that. Your test statistics 0.845, your critical values are these two numbers. You are not in the critical region, right? I mean, if you look at a picture of it, you've got negative 2 point something, positive 2 point something, and you're at 0.85 in the middle. So you are not going to reject. Step 5. I'll put it over here. Do not reject H0 because T0, which is equal to 0.845, is not lower than negative 2.032 or higher than positive 2.032. In other words, it's not in the critical region. All right, now what about the p-value method? So if we did p-value, that would be equal to, well, I guess it's kind of interesting. All right, equal to t dot dist dot 2t, because it's a two-tailed test. Then you take that test statistic, and you need it to be positive. If it wasn't a positive 0.845, if it was negative 0.845, you'd have to take the absolute value of it. Matter of fact, you can do absolute value in here. It's not going to hurt anything. Absolute value, ABS, parentheses, parentheses, comma, and degrees of freedom is 35, take away 1. And there you go. That's the p-value. Okay. So you are going to not reject null hypothesis because that p-value is greater than your alpha, for sure. All right, let me write that up next time, and then I will also show you StatCrunch.